for numerical method 2 class. So last time we proceeded with the QR decomposition of a matrix. We saw that there are two approaches when it comes to factorizing a matrix using the QR form. The first is the QR factorization via Gram-Schmidt process. And the second method is the QR factorization via Givens rotation. So in the last class, we saw the geometric meaning of the Givens rotation. So we apply the rotation and we generated the expression of the Givens rotation, right? The Givens rotation is an orthogonal matrix, meaning that the transpose of Q is equal to its inverse, or Q transpose to Q is equal to the identity matrix. So that's what we saw last time. And we use that information. To develop an expression of the QR decomposition. And when we parted last time, we look at some examples. So that's what we are going to do now. We are going to go back to those examples and make sure that you understand them step by step. Step by step. So that's the most important thing. Be able to understand how to apply the QR factorization step by step before we proceed. Okay. So the first example I'm going to use this slide. Okay, so we are going to go to the example. So in the first example, we are given a matrix. So we are given this matrix. A equal to 4, 3. Zero, -3, 4, 12. Then 5, 5, 0. Okay, so we are asked to perform the QR factorization via Given's rotation or using Given's rotation. Good. So remember that the purpose here is to convert A into R, right? R1100, R12, R220, R13, R23, R33. So this is the purpose. And to do that, we need to apply Given's rotation to A. And that is done by applying a certain Given rotation to A in order to obtain this. Right. That's the idea. Now, if you look at A, so if you look at our matrix A, to obtain this, we need to zero this entry, right? Yes?
Did you share a different screen, not the slide?
I beg your pardon?
I can't see where you are writing.
Ah, so you can't see.
Yes.
What do you see on the screen?
I see the notes slide.
So you can't read.
Yeah, I can, but let's just continue.
Okay, so if you can't read, let me do this. I will refresh. Can you read now?
Okay, yes, sir, that is what I wasn't seeing. So I was seeing a different thing. Thank you.
Oh, no problem. It's always good to communicate so that I will know that what I'm doing, you are following. Otherwise, I'll be talking to myself. Okay, so as I said, this is the purpose. We want to transform this into that. And for that, obviously, we will perform operations on A. Performing operation on A means that we multiply A by this, which, as we saw, is our Q transpose. Because when you get Q transpose into A equal to R, we just multiply both sides by Q, right? That is, we have Q transpose A equal to R. So this is equivalent to, we just multiply by Q on both sides. This is equivalent to A equal to QR. Right. So we'll be multiplying A by this given rotation. And in the process, those zero will be created. Those zero. Okay, so at the first stage or first step, we create this first zero. First one, we 0, 3. So this 3 should be 0, that entry. And remember that because in a note, we use a two-dimensional matrix. That's a 2 by 2 matrix. And in our 2 by 2 matrix, what we had something like this. And we use this, which we transform into R110. So meaning that when we perform our transformation, we make sure that we have a vector of R2. And what we try to zero is the second entry of the vector. So you see that this is transformed into that. So what has been zeroed is the second entry. So this is what was 0. Right. So we will do exactly the same thing here because we want to zero this entry, which is the second entry of this vector. Right? So we will take 4, 3 as A11, A21. Right? So A11, A21 will correspond to 4, 3, which we will convert into, and the multiplication of A by the given rotation will give us the R11. So that is roughly what we are going to do. Okay, now to construct our given rotation, we know already that this A11 is this, that is I. And the second one is J. So we have I, and here we have J, right? And because we want a 2 by 2 matrix, so this will be our 2 by 2 matrix. So this will be I, and this will be our J. And if you recall, when we have ij, to consider a given rotation, we do exactly the same thing. I, what is the value of I? I is equal to 1, j is equal to 2. So to construct j 1, 2 of theta, because we take the value from here, as I already told you, read it from here. We start with the identity matrix. Remember, we modify the identity matrix when we construct the given rotation matrix. We start, because if you see, this matrix is 3 by 3, so we construct a 3 by 3 identity matrix. 1, 2, 3. All the other entries are 0, because that's our identity matrix. Right. Now we use, so this is, okay, yeah, of course, all this is part of the explanation process. I'm taking time to do all this so that you understand that once and for all, and there will be no question. Even for those who are not currently attending the class, since the video is being recorded, some might ask questions or they might have issue. So that's what I'm writing all this detail. So we start with I3, which is the third or the 3 by 3 identity matrix. So we start with the identity matrix. We modify it. We modify this identity matrix. And how do we modify it? We use I to be the row, first row, J, first column, sorry. We use both to be to be rows and columns. So I is 1, J is 2. So meaning that we will look at I equal to 1 in terms of row, J equal to 2 in terms of row, and we do the same thing in terms of column. J and I equal to 1 in terms of column, J equal to 2 in terms of column, and the remaining one, because we are in R3 or 3 by 3 matrix. Right. So we use this identity, we modify. So you see, if we do that, they will intersect at this point, and that point, at those 4 points. And remember that here along the main diagonal, we have 1, 1, and then 1 for the identity. And we have 0 here, 0 there. All the other elements are zeros. Right. Except these 4 points where these lines and horizontal and vertical lines intersect. I will replace those intersections of these 2 lines, horizontal and vertical line. Where they will intersect, that's where I will put my S and my C. Remember that C is along the main diagonal like this. And then we have S, negative S, right? So let me erase and rewrite it properly. So here are the intersection points. So at those intersection points, we have C here and another C here. And here we have S, and here we have negative S. So that's how we construct G1, G12, 1, 2, 1, 2 intersection. That is from modifying identity. Yeah? We start with the identity and we modify it. right? So where the point, where those 4 lines will intersect, along the diagonal, we replace the ones with C, and the off diagonal there, we replace the intersection with S and negative X. That's exactly what we are doing. Okay, now that will be our G1, 2. Okay, now we know the formula for our C. We know that C is, we know already the value of C. C and S, they are given by this. This is the value of C, and this is the value of S, right? So this is C. C is equal to this value, and S will be equal to negative 2, 1. Because remember, we start with the first column, and the first columns are only these 2. A11, A21. So we have in the numerator 11 and 21 only. 11, 21. For S, you have the negative. And the denominators are the same. Okay, so that's how you construct your S. So we can compute this. So what will be C? I will proceed with the calculation. Yeah, it's a bit slow. Okay. So I will proceed with the calculations. So A11 is 4, and A21 is 3. So here we have 4, and, sorry, and this will be square root A11 will be 4 square plus 3 square. So this is 16 plus 9, right? 16 plus 9, which is 25. Square root of 25 is 5, right? So this is our C. C will be 4 by 5. Are we together? Are we together?
Yes, sir.
Okay, now what about this one? Okay, I can even write here. So I say for 3, so this will be negative 3 by 5 also. Is that okay? Okay, so we now take these values and substitute in the matrix. So thus G 1, 2 of theta be equal to, okay, now we substitute those values. C along the diagonal, so C is 4 by 5, 4 by 5, and here you have 1, the identity, 0. No, here you have S, and S is negative 3 by 5, and then you have the negate of that, minus S, which is 3 by 5. And the remaining entries are all zeros. Remember, we are modifying the identity matrix. Now you see that here we have the same denominator, which is 5. Right? You have 5 here, 5 there, 5 here, and 5 here. So this one can be written as 5 by 5. Now, if we factor by 1 by 5, what do we have? This becomes 1 by 5 into, that's just to make the things easy, I mean simpler inside. So this will be 4, negative 3, 3, 4, and here we have 0, 0, 0, 0, 5. So that is exactly what we do all the time, even though all these steps are not explicitly mentioned in the notes. So that is what we do. You should be able to write that yourself and see that if you factor here, this is what you get inside. So this is our J12. So if we take this J12 of theta, we multiply by A, automatically this first entry will be 0. This 3. 3 will be 0. Right. Okay, so that's what is being done. So that's equal to, we take this, okay, into A. So A is 4, 3, 4, 3, 0, then negative 3, 4, 12, 5, 5, 0. Okay, so this is what we have. That's our A. Now, if you perform the multiplication, the 4 in this case will remain, right? And then the 0 will be created. So we will get 4, and then the 0 that we want to create will be created there. This will remain unchanged. And then for the second column, 0, 5, 12. 0, 5, 12, 7, 1, 7, 1, 0. So that is what you will get when we multiply. Okay, so you see that at this stage we are done with the first column because we already have this is already 0, so we are done with this. Now what is the next step? Is to 0 this entry to obtain our upper triangular. We are done with this, so this is done. Now this is what we need to do. We need to 0 that entry. Now in order to do that, remember we need to have a vector with 2 components like A11, A21, like this, and we 0 what is below. So to do that, from here, what we will do, automatically if we want to 0 12, the entry above 12 is 5. So meaning that we'll be using 5, 12 as our new A11, A21. And this we need to convert it into something of the form. So meaning that we are trying to 0 this and this 12. So we will repeat exactly the same thing. Same thing. Now, what is the value of I? What is the value of J from this matrix? Right? This is like our A prime, if you want, or I can call it A1. I apply this to A. What I obtain here, I can call it A1, and I repeat the process. Right. I repeat the process exactly as I explained here. So this I here is 2, J is 3. Right? Because we have this, because we want a matrix. So the matrix that we are operating upon is this one, right? So we are operating upon this matrix. We are operating upon the matrix 5, 12, 1, 0. So you see that we bring it back to R2. And we repeat the process, we 0 this. Right. So that is exactly, you look at that, if you look at that way, you will understand properly the procedure. Okay. No, so this is 2, 3, 2, 3. Okay. I is equal to 2, J is equal to 3. Similarly here, I equal to 2, J equal to 3. So that is where we are here. Yes?
Is that not supposed to be 5? A1, that first entry.
5. Which entry?
The first one, where there is 4.
This entry?
Yes.
You say it's supposed to be 5.
Mm.
Okay, but it's easy. Let's quickly check. let's quickly check the computation. So we take this, we have 1 by 5, and then we have 4, negative 3, 0, right? And then we multiply by this entry, right? 1, 2, 4, negative 3, 5. So 1 by 5 into, so this is 16, right? Plus 9, okay, plus 0. So this is 25 by 5, yeah, so that's 5. Yes, so this is 5, correct, thank you. Any other concern? Is it clear for everybody? Oh, sorry, it's fine. I wrote 4 again. Okay. All right. So as I was saying, so this is the procedure. We repeat exactly the same thing. So now what we are going to construct, we construct G two, 3 theta. So I start with the identity matrix as usual. So this is our identity matrix. And then we use what we said, row, column. So you have these 2 lines and these 2 lines. So you see that they intersect at this point. All right. So meaning that I will modify these 4 entries and substitute C along the diagonal, C, negative S, and 0. Okay, and S. So I will quickly erase that. Right. Okay, to just indicate that these are the point that will be substituted. So here we have C. We have C along the diagonals, and then S, negative S. And we know how to compute that. We use the formula. We repeat exactly what was done there. We know that this is our A11, this is our A21. Right. So we repeat exactly this. We repeat that computation. Right. So A11 is this one. A11 is 5, A21 is 12. Are we together? Are we together? I am expecting you to say something. Are you still there? I can see Kashopi, I can see Aushona.
Yes. Okay.
I can see Camelo, I can see Johanna, but they are all, I don't know what I will say for them. They don't want to say anything. Hmm?
Yes.
All right.
Sir,
That's good. Yes.
for the S, can you make the A? Can you add A1 at the A2? The
I beg your
square
pardon?
root of A. Can you see at S
Oh,
ne?
yes. 2, 1.
There is a 1 missing at A2
Yes.
1 squared under the
Yeah,
square root.
thank you. Yeah, thank you. You're right. Okay, now we compute that. We compute that that square root. So square root of A11 square plus A21 square will be square root of 5 square plus 12 square, which is square root of 25 plus 144, right? Which is equal to the square root of 169, right? 9, you have 9, 4, 6, 1, that which is 13. Right. Anyway, that's calculator. You just use your calculator, it will give you that. So meaning that C is 5 by 13 and S is negative 12 by 13. So if we do exactly the same thing, we obtain to be, obviously I would factor directly. So okay, now you see that the position will be here like this, and here you have identity and 0 0 0 0. So this 4 position will be filled. This will be C S negative S, like that. But because the common denominator is 13, because this one, I can write it as 13 by 13, and I factor by 1 by 13. All right, so you all understand that. I don't need to repeat it again. So I will just put that factor in front, 1 by 13, like this. And then I will replace this. We know already the value of C, the numerator of C is 5. So this will be 5, 5. And then negative 12 here and 12 there. So we replace 5, 5, negative 12 here, and 12 here. So this is what our G23 is supposed to be. Now, if we apply this to A1, but remember A1 is J23, where is it? A1 is this one, right? But we'll write that at the end for now. We know what it means. That is equal to, take this into this. Okay, it's 500. Let me try to write it here. 500. Then 0, 5, 12, 7, 1, 0. If I'm not mistaken, let me check. 5, 12, 7, 1, 0. Good. This one. So this is what we have. So if we perform the computation, we should be able to get the following result: 500, 013, 5, 0, 0, 0, 13 here, and then 0 here, and the last column will be 7. The first 7 is not modified, and then 5 by 13. By 13, and this will be negative 12 by 13. So this is what we should have. But you see, it's already in the form that we wanted, right? It's already in the upper triangular form. So that is our R. Now, to get Q, what should you do? So this is R. It's already in that form, the form that we wanted. So this is R. So now let us rewrite things properly. So this is G21, and A1 is G12 applied to A, that gives us R. Right. Now we want to find the value of Q, right? We want to find Q. Now remember that these two are orthogonal matrices. Now if I want to get A, I will multiply by this. So I will take the transpose of this, multiply, and then the transpose of that, multiply. So this gives us A equal to what? R into the transpose of this, and finally we transpose this. And which is what? This is G23 into G12 all transposed. So we compute this and then we transpose. You get exactly the result as on the slide. That will be your Q. Right. We have each one of them. We don't even need that. We just take this. Anyway, this is our Q. So Q is this. Right. So after computation, we finally obtain the value of Q. So let me quickly write those values for you according to the slide. You can check those values for yourself. So the values are as follows. So here we have a factor of 1. One by 65 into first column 52, 39, 0, negative 15, 20, 60, 36, negative 48, 25. And you can always recheck to make sure that when you multiply this Q by R, it gives you A. Okay, so we will stop. We still have 5 minutes for the end. Huh? What time is it? 25. 11:30, 12:30. Okay, we still have 5 minutes. Okay, so that's our Q. We are there. Okay, so roughly speaking, that is the. I hope this explanation, all these details are. I hope things are clearer for most of, if not all of you now, with all this explanation. I didn't want to skip this. I thought it would be important to do that step by step with all of you so that you understand all the details. So if you were confused, I hope things have been clarified for all of you. Do you appreciate what we have done? I think it's clearer for you.
Yes, sir.
Good. Okay, so what we will do, we will proceed. We will proceed. Of course, we are left with 5 minutes, so maybe I can say something quickly. Can quickly say something. Yeah, we are done with that part. Now, the next step now is the householders method. I'm going to talk about the householders method. Even though the comprehensive test, you are writing the comprehensive test on Friday, right? You know that. Hello. Okay. So
Yes,
yeah, so you are writing the comprehensive test on Fridays, so it will not be wise, I mean, to include this part, because the concept will really be new to you. So the scope will go up to this part, the QR. It will stop there. The scope will stop here. Now the householders method will instead be for the second opportunity. I mean the supplementary, right? Because I'm going to introduce. Oh no, we'll talk about that tomorrow anyway. But please go and read, right? Read this householders method to understand the steps of the method. But I think I still need to catch up to okay, because after that it's just a Jacobi. And Jacobi is not long. Just explanation and some example. Okay, so we'll be able to convert that by Wednesday, because remember I owe you 2 classes, right, that we missed. So I can catch up and cover that. Okay, I think let's stop here for today, and please go and read householders method, because that's what we'll be discussing tomorrow. Okay, thank you for your kind attention. God bless you, and see you tomorrow. Shalom, bye-bye.